Welcome to the question number 2. This is for the 5th week of the homework portal. This question is a wonderful question. That's what I have seen so far in my teaching experience. Which teaches you each and everything or every part of the kinematics, especially for the free fall, what we have learned so far. Okay, and also includes some part of it from the kinetic energy, calculation of kinetic energy, potential energy, how does it vary. So many things it incorporates into. So if you do this one question, I think you would have learned really a lot of concepts from here. Okay, without wasting our time, let us continue. So this, as I said, is for 25 marks. So I have set up the timer for 25 minutes. Let me see whether we will be able to solve this in 25 minutes. Okay, now a firework rocket is fired horizontally upwards from the ground. It accelerates uniformly from this is an acceleration of 8 meter per second square for 5 seconds. The value of A is given, the value of time is given. Which means what? You are having from the ground, you are firing it here. So this goes upwards, okay, and it keeps on increasing its speed for 5 seconds. 5 seconds at a rate of 8 meter per second square. Acceleration so much. So what will be the final velocity here? You can use V equal to U plus AT here, right? Which will be U equal to 0, A is equal to 8 and 5 T is equal to 5, which should be 8 into 5 should be 40. This should be 40 meter per second. When it reaches this point, when the acceleration until here, until which the fuel of the rocket is all been used. So until here there was a fuel and after here there is no fuel. Okay, so here it is zero fuel condition. Sketch below a graph to show how the velocity of rocket changes with time from the moment it leaves the ground until the moment it returns to the ground. Why should it return to the ground? Let us understand the dynamics here. So from here to here, let me say this is your point O, this is your point A. Until point A, what will happen? The rocket's fuel has been used, and as a result of it, in 5 seconds it has acquired a speed of 40 meter per second. After this, what will happen? Gravity will once again pull it, right? Gravity pull it because it's a firework rocket. Okay, so the value of G will always remain a constant. It can't go to 10,000 kilometers in 1 second, right? So therefore, firework rocket, let us also find out what is the height it goes away. So therefore, so the velocity now here is 40 meter per second. The next second, what happens to the velocity? Velocity will reduce. Why? Because gravity is pulling. So as a result of it, what will happen to the particle? What will happen to rocket? Will it still go upwards? Definitely it goes upwards. It will still go upwards. Okay, but the velocity will keep on reducing. So velocity is 40, it could become 38, 36, right? 38, 36, 30, 25, 20, then 18, then 4, 3, 0. When it reaches this point, it becomes 0, which means it doesn't have any kinetic energy. All its kinetic energy has got converted into potential energy. Now what will happen? The rocket has to fall down. When it falls down, what happens? Now the velocity starts from 0 here, then 2, 8, 15, 27, 35, 40, 45, and it keeps on increasing like this until it reaches the ground, right? This is what will happen. Okay, now we have understood why should the rocket, what happens to the rocket. There are totally 3 stages here. The first stage is your acceleration stage. Second stage is the stage from which the zero fuel to the maximum height it reaches, and the third stage is from the maximum height it acquires a downfall. Okay, these are these stages. Now let us read the question. So sketch below a graph to show how the velocity of the rocket changes with time from the moment it leaves the ground. Okay, we need to draw a velocity time graph. I'll draw a velocity time graph like this. This is your V, this is your T. Can it have a negative axis? Velocity can have negative also, right? So therefore, I'll put only one more here. Okay, now velocity time graph from the moment it leaves the ground until it reaches, and okay, mark on your sketch the time t1 at which the fuel has run out. At a time t1, at this time t1 the fuel has run out, and then at the time t2 at which the rocket reaches its maximum point. So this is your t1 time, so your t2 here. The time t2, this could be your t2, right? T2 should be greater than t1. It cannot be inside, it should be outside only, right? And the time t3 at which it reaches the ground. Time t3, I'll put this time t3 a little bit far away. Time t3 where it reaches the ground. Okay, we need to draw a graph. Know that you are not expected to give any quantitative values of the velocity and time, and air resistance can be ignored. Okay, let us start with this. So first, what happens? So initially a VT graph will show a straight line like this, right? It will show a straight line like this until it's t equal to time t1. So this is what it is. Okay, this will be your V max, and it says okay, you need not give the values of it, so I'm just keeping it V max over here. Then what happens? The velocity after reaching V max, it keeps on reducing. See here, I already shown you it reaches V max over here 40 meter per second, and after that it becomes 38, 36, 35, 34, 30, 10, 5, 4, 3, 2, 0. Okay, so that means it will reach a value equal to 0 when it reaches the maximum height. It will reach a value equal to 0 when it reaches the maximum height. So therefore, you will once again get a straight line which intersects this point. Now, why should this be a straight line? Why can't it be a curved line? The reason is because, see, here there is a deceleration. Here the acceleration was seen to be 8 meter per second square. Here there is a deceleration. What is the value of deceleration? Deceleration is nothing but 10 meter per second square. How do I know this? I know this because, you see, it's a gravity over here. Now you see, this is 8 and this is 10. So is my slope correct? So this slope, if it makes an angle of something like theta over here, this value of the slope, so how much will this theta be? It will become more steeper over here. See, is it more steeper or lesser steeper? This is a lesser steeper, which means this way I should not write. Let me erase this. Let me erase this and let me write the correct value of doing it. Okay, right. Now let me redo it once again. Right, now we'll take this one here like this. This is your time t, this is your time t1. Now I should get a sharp fall like this. Now is it fine? So it doesn't look like an isosceles. So this side area is more, this side area is less. So this is your time t2. And after this, what happens? Now what is this point? This is the point at which the particle reaches the maximum height, right? So if you want, I will write down at time t1, run out of fuel. At time t2, maximum height point. Okay, we are saying two things. Now from t2, what happens? It has already reached the maximum point over here. From this, it has to fall down directly here. When it falls down directly, what will happen? The velocity is negative because it takes a U-turn at the top, right? So when you say velocity is negative, that means this line should be extended downwards. Now should this have the same slope as this one? Definitely it should have. Why? Because here also a gravity of minus 10 acts over here. Here also a gravity of minus 10 acts. There's no difference in the gravity. Okay, whether it is going upwards or downwards, the same gravity will act. So therefore, it should extend this line. Then what should happen? Now it has gone all the way along, and once again it should come down all the way along. Whatever is the vertical distance carried, the same vertical distance should be described downward also, right? It has gone from here. It has gone from here to, let us say, point O to point A. This is when fuel ran out. From point A to point B, this is your maximum height. Why did it go up? Because it had some kinetic energy with it. Okay, and as a result of it, the velocity from here, from V max, it started reducing to V max by 3, V max by 2, and so on. It came here where V max is equal to 0. Okay, when it came here, what is this point over here? This is your point B. So let me write down the same points here. This is O, this is your point A, and this is your point B over here. After B, what happens? It has to return back. So when it returns back, it reaches the ground once again at this point. Which means what happens? The distance covered here is equal to distance covered here. The distance, okay? So when you say distance or displacement, how do you calculate in your VT graph? You calculate it by the area here, right? Which means the area that you get here should be equal to the area that you get here. So therefore, I will extend this a little bit more and then I will drop over here like this, right? So this is your point T3. Let me extend this. This is your point T3, right? T1 is done, T2 is done, this is your T3, and once again, this is T3, T3 is, what is this point over here? The negative velocity, okay, T3, so when it reached the ground, when the rocket came and fell onto the ground, or about to touch the ground, the moment it touches the ground, then what will happen? See, it is at this point, it's at this point over here, it's just touching the ground, not to touch the ground, okay? Then what happens? The velocity is very high. The moment it touches the ground, what happens? All the kinetic energy is given to the ground over here, which means the velocity becomes 0. So therefore you see there's a sharp decline over here. Okay, this decline is much sharper than this one, such that this area is equal to this area. So therefore you put O, A, B, C, and this is your value of t, right? D is the time, CD, that is this time that you have over here. This time that you have over here is nothing but the time taken by the rocket to just touch the ground and come to rest, right? So you have drawn all of them. Now, how much marks is this? This itself is taking a long time for me. Okay, this was 6 marks. Let us see how is this been divided. The first mark is given for axis, drawing down the axis properly. The second mark is given for the different slopes. Have you drawn the slopes correctly, or have you just drawn the slope just like this? See, this is much larger slope, okay, lesser slope over here. This is a very same slope, the same slope comes out on here. This is a very abrupt, which happens in a very shorter interval of time, right? So this you need to take it, okay. And then the third one is here. So you have written, now this is one mark over here. Then properly marking the point T1. For T1, one mark over here. For T2, one mark over here, right? And for T3, one more mark over here. So we have done all this T1, T2, T3 over here. And then what is that? The area here, the area OAB is equal to area BCD. So how do I know it? See, for example, if you had drawn a curve like this, okay, you have drawn this one correctly, drawn this one correctly, and suddenly you draw only so much. Now you see, so the shape of these curves won't be the shape of this curve. Shape of this curve could be the same, but you see, you can manually, okay, you can visually, you can inspect that this area is not equal to this area, so you will be incorrect, right? So therefore, this also will carry 1 mark. Okay, so with this we come to the first question we have completed. Wow, 9 minutes we have taken only for this. Okay, comment on the areas under the graph we have drawn. The areas is that area in the graph, sum of the area in the graph should be equal to 0. Reason is because net displacement is equal to 0 as the rocket reaches the ground. Okay, that's what you need to write. Then the following calculations, you may ignore the effects of air resistance and take the acceleration due to gravity. Calculate the speed of the rocket when the fuel runs out. What is it asking? Calculate the speed of the rocket. When the fuel runs out. We already done it, right? So from here it is 0, it comes over here, V equal to U plus AT, which is 40 meter per second. So you need to write down here. So you need to write V is equal to U plus AT, which should be 0 plus 8 into 5 seconds, which should be 40 meter per second. Right. Height that the rocket reaches when the fuel has just run out. Height. What is the height over here? We already have V here. We had U there. S can be written as U plus V divided by 2 multiplied by T. Average velocity multiplied by T. Why do I use this? Because the acceleration is uniform. So U is 0. What is V? 40 divided by 2 multiplied by time is 5 seconds. Which would be 2 1s are 2 20s are 20 into 5, which is 100 meters. Okay, so the rocket started from the ground over here. It reached the point A. From point O to point A, distance is 100 meters. I always prefer to write like this for a given reason. Okay, maximum height reached by the rocket. Okay, now what is the velocity here? V is equal to 40 meter per second. Now the rocket goes upwards all the way along until point B, and here V is equal to 0. So how do I do here? I need to find what is this distance. Let me call this a h over here. The total distance is nothing but the maximum height, right? So 100 plus h is nothing but your maximum height. So how do I get the value of h? So if this is 40 and this is 0, I need to get what is the time. If I want to use this equation, okay, I can again use this, right? This you can take this as initial velocity, this I can take it as final velocity, okay, and then time, if I know, I can do it. Do I get the time here? Is the value of time being calculated? Time is not calculated anywhere, okay, so I will not be able to get that. Is there any other method? Yes, you have one more method, which is that final velocity, initial velocity, acceleration. What is the deceleration? Why should go upwards? The deceleration is there. Deceleration is equal to minus 10, right? Gravity. So therefore what I will do is, you will use V square equal to U square plus 2A as formula. V square equal to 0, U square equal to 40 square plus 2 into A is minus 10, and to S is nothing but the h value. So therefore h is equal to 40 square divided by 20, which is equal to how much? 40 into 40 divided by 20. 21s are 22s are 2 into 40s are 80 meters, right? So this value of h is equal to 80. So thus the maximum height is equal to 100 plus 80, which should be equal to 180 meters, right? From the ground, it has traveled a distance of 180 meters. Okay, not a big distance. So the value of g fairly remains a constant. Okay, now let us move on to the next one. Time it takes the rocket to reach its maximum height. That also we have asked. Okay, time it takes. So now what we can do is use this equation. S equal to u plus v divided by 2. Now to use this, you have to be very careful. What is that? Now you need. So, okay. Now if I use this equation, what is this S here? This S is nothing but the total time. Now where is the acceleration constant? The acceleration is constant at two regions. See, it is constant in this region. It's a different constant. Here it's a different constant, right? Here the acceleration is seen to be minus 10. Here the acceleration is seen to be plus 8. So there are two different values. So therefore you should apply that equation S equal to u plus v by 2 into t when the value of acceleration is a constant, which means either you apply in this region or you apply in this region, any one of them. Okay, so maybe you can apply separately. So what you do is, see, this time is already known. What is this time here? This time is seen to be 5 seconds, already given. Okay, from ground to the point where the fuel becomes empty, it is 5 seconds. So here I need to find this time over here. So how do I find that time? So what you do is, what is the h? Now this value is nothing but h here. What's the value of h? The value of h we have got here is 80 meters. So we have got 80 meters is the height. What is u here? U here, you see, u here is the initial velocity at this point, which is 40 meters per second, and v is 0. So therefore this should be 40 plus 0 divided by 2 multiplied by t. When I do this, 2 1s are 2 20s are, now 21s are 24s are. So which means t should be equal to 4 seconds. 4 seconds. So what is this time t here? The time taken by the rocket to start from the point where the fuel becomes 0 to the maximum height where the final velocity becomes 0. So I'll write t equal to 4 seconds. What is it? Yes, total time. Total time to be 4 seconds plus 5 seconds, which is 8 seconds, 9 seconds. So total time is equal to 9 seconds over here. What is this time? This time is nothing but the time taken by the rocket to start from here and to go upwards. Is that what has been asked? Time taken it takes to fall from its maximum height to the ground. Oh my god, then this is not I required. Okay, this is your t up. T up. Oh, it's here. It's here. I have to write here. Time it takes for the rocket to reach its maximum height is equal to 9 seconds. Will this be equal to 9 seconds? Will the same 9 seconds be equal when it is coming downwards? Definitely not. Why? Because there's a difference in acceleration. Here the acceleration is minus 10. Here the acceleration is the 8 meter per second square. So therefore, definitely they will not be the same. So I need to calculate separately. Now how do I do that? Now it is something like you have a particle which is at a maximum height and you drop down. When you drop down, what happens? It is experiencing the same acceleration. So which equation can you use? You can use S equal to ut plus half at square, right? Where t is the time of fall from the maximum height to the ground. Now what is the value of S? S is nothing but the total distance. How much is it? We already calculated. How much is it now? Which is 180 meters over here, right? 180 meters. So this should be equal to 180 meters. This should be equal to u. What is u? When you drop the particle from here, what is the velocity when you drop? 0, 0 plus half into, what's the value of a? 10 over here. And what's the value of t? T square over here. Okay. So we need to find out this t down, right? So therefore, some of you might ask me, why a is plus 10, a should be minus 10. I agree, a equal to minus 10 over here. Then if this is the height, this is the height, the particle has been drawn from here, then what is this height here? 180 meters. See, this is your positive x-axis, this is your positive y-axis. Now this should be negative y-axis. So what should this be? This should be minus 180. So I'll put minus 180 here. So this should now be equal to minus 5t square, right? This minus and this minus 5 goes away. So t square should be equal to 180 divided by 5. Use our calculator to find what's the value of t. Where is it? It's here, right? So 180 divided by 5 is equal to 36. 36. So t should be equal to 6 seconds. So what is it we have seen? See, t down is equal to 6 seconds, while t up is equal to 9 seconds, right? It takes more time to climb up, but lesser time to come down. When is this applicable? This is applicable when the acceleration is non-uniform, okay? But on the other hand, when the acceleration is uniform, it takes the same time to go upwards, the same time to come downwards also, okay? Keep this in mind. So why is it called as non-uniform? The reason is because For the first 100 meters, it went upwards with 8 meter per second square. Okay, and after this, fuel got over, so therefore there was no acceleration. It had its velocity, redundant velocity, and this velocity, what should it do? It should be over here, it should be going upwards. So, but it has been pulled downwards. Who pulled it down? Gravity pulled it down. What was the acceleration here? There was no acceleration. It was a deceleration, which was minus 10 meter per second square. Now again I am telling you, do not add this, take the average and say net value equal to 1, net value equal to 2, minus 2. Don't do all these things. Okay, because the set of equations you are using it is applicable only when the acceleration is constant. You are not supposed to take the average acceleration. You are not supposed to take the sum of the two accelerations. These things will not work here. Okay, now on the axis below, sketch graphs to show how the GPE and the kinetic energy of the rocket vary as it moves from the ground to the maximum height. What we will do is, let us first put the scales. Whenever you are doing a graph, put the scales, put the axis first. So this should be your potential energy and kinetic energy variation, and this should be your height. Okay. Now first what we will do is, let us revisit the problem once again. Okay. To do the graph, you should have the data with you. Otherwise, you cannot do it. Though it has been very clearly mentioned, you do not need to, but to do it, we definitely need this. Otherwise, it becomes very difficult. It's not so easy here to work with this. So this is the ground. Starts from point O. Rocket goes upwards to a height of 100 meters. All the fuel gets over point A. It takes 5 seconds to reach this point. The velocity at this point is 40 meter per second, and the acceleration is 8 meter per second square. And from point A, since its velocity is there, so it keeps on moving upwards to a certain height, let us say point B, and at this point it has reached a height of 80 meters, and it has taken 4 seconds to reach the maximum height. And here the acceleration is minus 10 meter per second square, right? And here the velocity is v is equal to 0. Beyond this, it is unable to go because all its kinetic energy has been 0. So hence it tries to comes backwards. So this is what is being asked, has been given to you, or we found out so far. And here what we need to do is, we need to only look from the rocket's kinetic energy and potential energy variation as it moves from the ground to maximum height. So we need not worry about what happens when it comes downwards. Okay. Now this is what is given. Now what is the initial energy, initial velocity here? Initial velocity was seen to be how much? What is the initial velocity here? There was some initial velocity given here, right? With what velocity did it start with going upwards? So rocket is fired upward vertically. It accelerates uniformly from rest with an acceleration of 8 meter per second for 5 seconds. So initial velocity was 0. Okay. Initial velocity was 0. Okay. So initial velocity was 0 here. U equal to 0 here. Now we need to plot a graph of kinetic energy versus potential energy versus height, and potential energy versus height. Now kinetic energy, instantaneous kinetic energy, let me say T, is given by half mv square. Okay, and then what we do is, we know that v square is equal to u square plus 2ah. In this region, let me say this is 2ah h1 over here. So as a result of it, I can now write u equal to 0. This becomes 2ah over here. So this, what do I do here? Because a is equal to 8, I can have this. So kinetic energy T is equal to, let me call this T1. T1 is equal to half m into 2ah1. So thus I see that this is equal to mah1. So in other words, kinetic energy T1 is proportional to h1, right? Proportional to h1, which means you should get a curve, you get a straight line passing through the origin with the slope equal to m into a. With the slope equal to m into a. If a equal to 8 over here, I can now write the slope should be equal to 8 times m. 8 times m into h1, where m is the mass of the particle. Okay, so I will write like this over here. This is your height h1. This is your height h1. That means we have reached this point A. Let me write this as point A here. Point A, it is reached here. Now after this, what happens? The 40 meter per second now reduces to 0 meter per second. There is a deceleration, which means what? When the velocity decreases, kinetic energy also decreases. So this means the kinetic energy should now decrease like this. Now how should it decrease? See, the way it increased, the slope here is going to be 8m. The slope at which it decreases should be much more steeper. Why steeper? Because kinetic energy here goes with, okay, let us do this one also here. Kinetic energy T2 T2, let us say this is your time T2 at a height H2. H2 is what, 80 meters here, right? From here to here is 80 meters or totally 180 meters. Okay, so this should be equal to half m v square. And then what is v here? V square should be equal to 2gh. So because now it's under the mercy of gravity, so this should be half m into 2gh. So therefore this 2 and this 2 goes away, so you get this as mgh1. Okay, so therefore m into g is the slope here, which means this will be more steeper. The slope here will be higher over here. How? This will be 10 times m, right? So you will get a slope like this. You will get a line like this over here. Okay, so both we have drawn. Now kinetic energy is done. Kinetic energy is done. Now what is potential energy? Potential energy, now let us write down, where do I write? I write potential energy here. Okay, potential energy here. Potential energy is given by mgh, right? Which means it's proportional to mg. Oh, time is already up. Okay, potential energy is equal to mg into h, and g is equal to 10 over here. So you should draw a separate graph. It should be like this over here. Potential energy is equal to 10. So it should be like this over here. It should be like this over here, right? And then and after this, what happens? Even when it goes beyond this also, it's the same. So therefore you keep on going like this over here. Okay, so this will be your potential energy graph, and this would be your kinetic energy graph. Okay, now let us move on to the next one. The rocket plus fuel initially have a mass of 0.16 kg. Okay, mass is 0.16 kg. The initial mass of the fuel is 0.02 kg. This is mass of the fuel. This is mass of the rocket plus fuel. Okay, calculate the maximum kinetic energy of the rocket when all the fuel has been used. When all the fuel has been used. Okay, when all the fuel has been used, the mass of the rocket is nothing but 0.16 kg minus 0.02 kg, which should be 0.14 kg, right? We have to consider only mass of the rocket over here. So maximum kinetic energy of the rocket when all the fuel has been used. We are not looking at, okay, what happens to the kinetic energy when half of the fuel is used, a quarter of the fuel is used, and so on. We are looking only at the final one. So the final one will now be equal to half into mr into v square. What is v square? The velocity of the rocket or speed of the rocket when all the fuel has been used. What's that value? That value is seen to be here. Where did the fuel get over? Fuel got over here at this point, right? So which is seen to be 40 here. So therefore, let me write down this. This should be a half into 0.14 multiplied by 40 square. What will this value be? Let me take up that value as a calculator. It's here, which should now be 0.14 star 40 star 40 is equal to so much divided by 2 will be 112 joules, which will be 112 joules. Okay, so this is the way how you need to do it. Okay, thank you students. So this is one of the wonderful problems, and if you start solving such kinds of problems, you know, it's very easy for you to get a grade 7 and to get a maximum hold on this particular topic, especially kinematics. Thank you once again.